Back for another 8 Caillou challenge. This one's called Duck, Duck, Goose. The task is given an array of player objects in a position. The first position is 1. Return the name of the chosen player. Note that name is a property of player objects as denoted in this class over here provided for us. And look at the examples below to make sure you understand what the problem is asking. So you will be passed in an array of player objects denoted by these square brackets and in the method signature up here for players. You'll additionally be provided an integer index representing our goose or whoever's selected. And then it's your job to return their name. So you're essentially going to use the goose value to determine a valid index into the players array and find that player's name. Note the input limits they provided. It's going to be between 6 and 50 inclusive number of players, and the position can be anywhere from 5,000 to 50,000. So it's okay if you don't know about arrays. This is an 8 Caillou challenge, but the main challenge with working with them, or the thing that you need to watch out for, is that you don't access outside the bounds of the array. This is a major problem. And so you can imagine with values like 5,000 to 50,000 and with much lower player array sizes, a maximum of 50, we're dealing with a situation where we're indexing by a value that's much larger. And so the examples help us understand this. The first one and the third one are pretty cut and dry, right? They're saying take the first player, which would be A, right? A is the first entry in the array. So return A's name. In the third example, they gave you number 4, so it's d.name. But look at this one with 5, right? 5 isn't a valid index. There's only 4 players. So what you do is you can think of this like counting 1, 2, 3, 4. And for 5, you actually wrap around to the start. If the value is 6, it would go to B. 7 would wrap around to C, etc. So hopefully you can see that this is an issue of wraparound and then accessing the right value within the players array. So I think that makes the problem straightforward enough for you to work with, that you understand. So go ahead and pause the video, have a go at this, and unpause me when you're ready.
Bow to your sensei!
Okay, we're back. Let's start writing some code. So the big helper here, and you may not know this operator, was it's going to come down to a really handy operator we call the modulo operator. And that has to do with division. And so we use it a lot when we are accessing values inside of collections, namely arrays in this case. So we will use the modulo operator to handle this, to sort of chop this position value down from a very high value outside the bounds to sort of simulate it wrapping around however many times it needs to, and then finally getting a valid index within the appropriate size. So let's walk through this. Get rid of this boilerplate. And you know, if you've been with me, you know about my OCD. Let's put a space in there and separate our two things here. We should probably make a note about the class. They often don't do this in 8 Caillou, but they did give us a little stubbed out class here. And so you can see that we use classes. Just think of them as a way of making other data types. They're not the they're not the built-in data types that come with the C# language. Notice this string thing here, right? That's just built into the language. We didn't have to define string. Same thing with integer, right? Integer is built into the language. We didn't make it. But, and you even denote it too with the different color of if you have a nice IDE or the CodeWars browser here, you'll notice they use different colors for words that are recognized, right? Types that are recognized here, or keywords like even public. But anyway, I don't want to get too far off topic. These custom types then, we get to pick what properties they have in them. So they gave us this name property. So we're basically going to access the right element, and then we can access the property. It's similar to how you access methods. I mean, in a way, properties are methods. You can see these get and set. These are shorthand for getter and setter methods that are sort of implemented behind the scenes on your behalf. It's just a convenient shorthand that C# offers. They're called properties, but they essentially are methods. So let's try to calculate a valid index. First things first, it should have bothered you or it should bother you going forward when people do this kind of one-based indexing. We don't do this in computer science. We always start counting from 0. So the first thing I'm going to do is I'm going to decrement Goose. I want it to be a 0-based number so I can go into the bounds of the array. I'm just going to make my own local variable. You could do this all in one line, but let's just kind of step through this by the numbers for an ACAU. I'm going to say int index, and this is going to be my valid index. That's going to be guaranteed to be between 0 and the size of the array. So first things, I'm going to say Goose minus 1, right? So then instead of 1, 5, 4, I'm dealing with 0, 4, and 3, or, I want it to be that 0-based number that I'm used to working with in computer science. So that's why I did that. And then the big feature that hopefully you knew about that would make your life very easy. And it's okay if you look these things up, right? That's not cheating in programming. You're entirely allowed to look things up. It's this modulo operator, which is the % symbol, and we'll talk about what that does exactly. But I'm going to say players.length. Arrays have this property called length that gives you how many elements are inside of them. We know that arrays are of a fixed size. That's one of their properties. I'm sorry. The index here would be, the passed in value made into a 0-based number modulo the player's length. And you can think of this modulo, it's really the same as dividing numbers. So just like if I said 25 divided by 4, for example, right? We would say that's equal to 6 with a remainder of 1, something like that, right? With modulo, think of it this way. If I just gave you 25 divided by 4 in programming, you would give me the divisor's value, right? I'm sorry, the quotient's value. I'm mixing up terms there. The quotient. You would give me the quotient value. With the modulo, instead, it's still 25 divided by 4, but instead of returning the quotient, it returns the remainder. And so this is incredibly useful for accessing into arrays. So now we can say return players, and now we can use our calculated index value, and this will be guaranteed to be within the bounds of the array. We're sort of dividing out how many, whatever the length of the array is, we're dividing all of those times out, and we're just carried about whatever that leftover value is. That's going to be the actual index into our array. And if you wanted, you could write out numerous examples of this just to convince yourself that it always produces the right value. That could be a good exercise if it's not apparent to you from what I've just said. So I would think something like this will work. I'll remove my notes there. Int index, return player's index. Remember, Goose is looking for a string. So that's isn't this good? We checked. This is not a string, is it? This, when we index into the array, is going to give us whatever the array type is. So right now I have a player. This would actually throw an error, and if you know what, this could be instructive. So let's just hit test and see what happens. We should get an error. We broke the contract. I like to tell people that methods are like contracts. And you'll see cannot implicitly convert type player to string. That's what we're trying to do here. We're trying to return a player where the contract specifies a string, so you can't do that. We talked about in the opening that players have this name field, and that's precisely what the instructions asked us to return. So we're going to access that just like a method. We'll hit dot to access that property, and we'll say name. And now if we test, at least it's a string value. We know that name's defined that way. We hit green for our test. We'll hit attempt to run through all of the tests. There's more tests behind the scenes that you don't see. And it's telling us we passed the test. So good. I'm going to go ahead and submit this. Before I do, I'll show you, we did this by the numbers, but in the field, you're going to see people, they don't bother taking the time to make this separate index field. So if you wanted to, you could just take this whole bit right here, cut that, drop it right in here, and hopefully you can see that's the same thing. But sometimes in these beginner courses, when I lead with, if I go right into a solution like this, people, look at me cross-eyed, and, it can be confusing if you're new to programming. So hopefully that's clear. You saw me flesh this out step by step, so now I'll condense it to this for the solution that I'm going to submit here. They're going to make me run the attempt again because I modified the logic, which is appropriate. I could have made a mistake, but it says I still passed the tests. So I will go ahead and submit this as is. As usual, as I tell you, go ahead and collect those kata points. And this is a pretty simple example. Looks like they did exactly like we did. I just usually put spaces between my operators. But sometimes it's instructive to look through other people's examples. Like maybe you didn't realize this was valid syntax in C#. You can return from methods that way. So don't do this. Don't be this guy, okay? Yep, Among Us. You are voted off the ship here, buddy. So, but anyways, see if you can learn from other people too. You don't have to learn just from me. Anyway, you know where to find me if you have questions about this challenge. Otherwise, as always, I appreciate the view. I appreciate the likes and subs. I will see you in another one.